Welcome back to the Rhino JFR commands tutorial. Today, I will continue using a ring example to explain how to use the JFR Sculpt feature. Let's begin today's lesson. First, enter Sculpt Mode. Click the JFR Sculpt icon. Select the object you want to sculpt. Let's first get familiar with the JFR Sculpt Mode interface. First, this is the top toolbar. The first icon is the Brush Library toggle. Click to show or hide the Brush Library panel. Here, we can switch between various practical brushes to achieve different sculpting effects. I'll briefly demonstrate a few brush effects. That's the function of the Brush Library. Next icon. All options here are related to masking and hiding. Now I'll briefly show how to use it. Select the mask brush. Cover part of the ring's surface. The masked area cannot be edited. When I want to clear the mask, click this option here. When the mask edges are too sharp, we can use Blur Mask here to soften the edges. That's how to use the mask options. The options in the lower half are related to hiding. Switch to Lasso Hide, then lasso a part of the ring. You can then swap the hidden part with the fully displayed part. We'll explain the other options in detail in subsequent case tutorials. Next is the 3D Gizmo function. This function will be updated in the future. This is the Mesh Edit panel toggle. Here, you can reconstruct the meshes to adjust their number or apply mirror welding to the mesh. These are commonly used mesh editing functions. Next is the Brush Settings interface toggle. We can enable the brush's mirror function here, allowing symmetric mesh editing, or along the y-axis as well. We'll cover other brush settings in later cases. Today, we'll mainly focus on getting to know this interface. Next icon is the hotkey function. We can modify some commonly used shortcuts here. For example, change it to the number 0, then the front view shortcut becomes 0. Change it to F and the front view shortcut is F. Speaking of shortcuts, I'll take a moment to explain the system shortcuts. Most shortcuts are the same as Rhino's native ones. Right-click to pan the view. Control, Shift, and right-click to rotate the view. Hold right-click, then press Control and Shift to directly switch to the front view. Control and Z to undo. Control, Shift, and Z to redo. These are the more commonly used system shortcuts. Since JFR Sculpt supports graphics tablets, you can set the right-click function on your tablet's buttons. Next icon is Save File. Then the next one is Interface Editing. Here, we can scale the toolbar size. Adjust it according to your monitor size for a proper fit. Click here to restore defaults if needed. Additionally, we can move the tool panels freely. Arrange them as you prefer. The last icon is Exit Sculpt Mode. Before exiting, you can choose whether to keep the original object. Most of the time, I choose to delete it, so only the modified object remains. When re-entering, the current mesh and point counts are displayed in the upper right corner of the interface, helping us better manage computer resources and display more details. The bottom toolbar is mainly related to view and display settings. Left-click the first icon to switch to front view. Right-click to switch to back view. The first 3 icons support both left and right mouse clicks. Next is frame. Next is wireframe, which helps us check whether the current density of the mesh is appropriate. Next is ghost display. When there's a reference image in the background, this command lets you see the reference image behind. Next is solo display, which shows only the object you are currently sculpting. Perspective mode. Objects appear larger when closer, smaller when farther away. Click the icon again to turn it off, or switch to a front view to exit perspective mode. Press T to switch to top view. The last one is full screen command. In full screen mode, we can sculpt immersively. Click again to close it. That's a general introduction to the JFR Sculpt Mode interface. Next, I'll explain how to use JFR Sculpt Mode with a ring case. This is a ring I made earlier. Now I'll share how I design it. First, place it in the upper left corner as a reference. Step 1. Determine the gemstone size. Select a round gemstone. A diameter of 4 mm is sufficient. Next, create a bezel setting. Take a profile from the library. Choose this one. I'll modify this profile into another shape. Use the Scale 3D command to scale it. Set the bezel width between 0.5 and 0.6 mm. Adjust the shape by moving control points. Then use the Simple Curve command to edit this profile. We can add a shallow groove here. The bezel generated from this cut surface is suitable for both production and rendering, so there's no need to modify the shape again before rendering. The bezel corners can be rounded. No need to be too sharp. The bottom can also be rounded. Use the Revolve Preview command to generate the surface. Then adjust the cut surface to optimize the bezel shape. Make the bezel a bit thicker to prevent the diamond's bottom from showing. Next, create a ring-sized circle. Select your preferred size. Move the bezel to the top. Offset a circle by approximately 1.9 mm for thickness. Then move it up 4 mm. Lock them as reference lines. To make the bezel blend better with the overall ring, we can curve the bottom of the bezel using the Bend command. Remember to enable symmetric. Next, create the basic shank shape. Take a rail curve from the library. Scale it to match the reference line size. The position in the image is relatively long, so we need to edit this rail curve and extend it a bit. Adjust it to align with the reference line. Then offset the curve by 1.9 millimeters for thickness. Show the curve control points. Use JFR scale to align them with the reference line. The scale command allows control points to move along the normal direction. Since the control points are aligned with the normal, the surface lines created will be smoother. Use the Roll 1 command to edit the control points, ensuring they always align with the normal direction. Now, adjust the rail curve into a curved shape with reference to the image. Draw the ring's profile. I usually use cycle curve to quickly create a basic shape. Then modify it. Select control points to reshape the profile into a rounder form. Now the profile is ready. Use Dual Rail Preview to generate the ring shank. Seal the ends of the ring shank. When creating the shank, remember to select this profile position. If you need to adjust the shank width, you can directly scale the profile. Then use the Make Uniform command in Surface Tools to smooth the ends of the ring shank. Adjust the local width. Shorten this part using the Rotate command. Now I'm going to widen the rest of the shank. Modifying the ring shank this way is very easy. Next step, create the basic shape for the branch extensions. Use the same method. First, draw the rail curve. Select the curve. Use Offset curve. Adjust control points to form a curved shape. Sometimes we can use the Flip 1 command. This way, we don't need to switch to the front view to rotate. Combining multiple tools makes the process much easier. Duplicate a profile. Generate the branch using Dual Rail. If the branch is not wide enough, widen the profile. Continue adjusting the branch by editing the rail curve. Then apply Make Uniform. Further adjust the branch shape. Thin the end to create a thick to thin transition. Next, create the second branch. Use horizontal mirror. Rotate it to the correct position with the Rotate 2D command. This part is too thick. Select these control points. Scale them to the left using Scale 1D. Continue adjusting the curve of the shape. We can use Flip 1 here to flip the end of the branch to the upper left. Ideally, the control points should be perpendicular to the entire branch, ensuring the surface remains smooth and free of distortion. Do the same for this part. Thin the end with Scale 1D. Once half of the ring is done, duplicate the other half. For a more natural look, we can make the branches slightly asymmetrical. Modify local areas using Rotate 2D. The branch shape is a matter of personal preference. No need to match the image exactly. The branch point can be slightly wider. Rotate. These branches and the main shank don't need to be specifically joined. They must remain as simple surfaces to generate wood grain. Poly surfaces cannot be used for this. However, for wood grain continuity, the bottom of the ring needs to be connected. Delete this row of control points. Use the Loft Surface command. Select the edges. The direction is incorrect. Need to reverse the U direction. But the connected result is wrong. The closed seams or UV directions of the left and right shanks are inconsistent. We can see that these two seam lines are not in the same position. If you can't find the seam lines, try changing their color. So now I need to adjust the seam line positions first. Use the Adjust Closed Surface Seam command. Press Alt to set the seam line here. Ensuring the seam lines are in the same position simplifies the rest. The left surface direction is reversed. Reverse it by right-clicking Flip Direction. Delete the control points of the left shank. Finally, use the Analyze Direction command to check the UV directions of the left and right shanks. We can see the UV directions are different. The right shank's U direction is to the right and V direction is upward. We just need to set the left shank's direction to match the right. First press ESC to exit, then reverse the UV direction of the left shank individually, so that the UV directions at the same positions of both shanks are consistent. Then use the Loft Surface command to connect the left and right shanks. Press space to confirm generation. The remaining step is to adjust the slightly deformed shank shape. Now I'll start generating the wood grain texture. Use Image to Relief. Select Surface. Choose a wood grain texture. Let's use this one. The texture details are insufficient. Increase the clarity parameter. Set vertical count to 1 and horizontal count to 3. Now the texture effect is starting to show. Adjust the thickness to increase the relief intensity. Reference the surface thickness for the generated thickness. Convert to solid. Although the texture looks dense now, it will become sparser after smoothing with the sculpt feature. My main goal is to quickly generate the overall relief shape with this tool, then sculpt on top of it. Next, apply the same effect to the other branches. Use the same method. If you encounter this issue, you can solve it by modifying the surface's UV direction. Reverse the U direction. Do the same for this one. Then run the Image to Relief command. Set clarity to around 200. Just a quick note, different textures need different settings, so tweak them to get the effect you like. Stretch it appropriately. Adjust the thickness. Convert to solid and finish. If you want this branch to look significantly different from the others, you can use the Image to Relief tool to generate it separately. Then, shift the texture horizontally. These parameters are not fixed. Adjust according to personal preference. Hide the surfaces used to generate the branches. Next, I'll enter JFR Sculpt Mode to further sculpt this ring. Let's continue working on the ring. First, adjust the positions of these branches. Temporarily disable Object Axis. Use Flip 1 to flip this branch to the right. Apply the same command to the branches on both sides. This will make the top of the ring look more compact. Select all curves and hide them. Select the entire branch ring, then enter Sculpt Mode. They are currently separate. Need to reconstruct them into a single piece. Since the ring has many details, we need to generate more mesh faces. As the ring is a small product, many fine textures cannot be produced, so I'll first smooth out these tiny details. Hold space to increase the brush diameter. Hold Shift and left-click with the mouse or tablet pen to smooth. The current brush strength is too high. Switch to the smooth brush. Hold space to reduce the strength, so that not all details are smoothed out. I still think the smoothing efficiency is too low, as the left side of the ring also needs smoothing. Enable X-axis symmetry for more efficient symmetric smoothing. Note, don't use too much strength when smoothing. Retain the ring's overall structure and as many details as possible, except for minor imperfections. Next, work on the front view. Enable Y-axis symmetry. This way, when smoothing the front view, the back of the ring will also be smoothed. That's the function of Y-axis symmetry. Some of the more prominent details should be preserved as much as possible. Next, smooth the inner part of the ring. The inner side will directly contact the skin, so it needs to be as smooth as possible for comfort. A detail to note, smoothing the inner shank may affect the outer side. We can use lasso mask to cover the affected areas. Masked parts won't be affected by the brush, while unmasked parts can be edited normally. First, select lasso mask. Enable X and Z-axis symmetry. Then mask the inner side of the ring shank, the part we want to smooth. To remove part of the mask, hold Alt and lasso the area to unmask. Use inverse mask to cover the outer side. Blur the mask edges. Now smooth the inner side of the ring. Switch to the smooth brush. Use a higher strength. Try to smooth out all textures on the inner side for better comfort. Finally, clear the mask. Next step, adjust the ring shank width. Disable X-axis symmetry. Switch to brush 2. Use a large diameter brush to widen the shank like this. Widen this area the same way. Adjust the rest of the ring accordingly. Basic sculpting operations are simple. Most of the time is spent shaping with brushes, and all brushes work similarly. This area is indented. Switch to the back view. Press S to solo the ring for editing. The local part of the shank is too thin. Thicken it using the same method. However, thickening this way may affect the inner side of the ring. In addition to using the mask brush, we can enable backmask. This prevents the brush from penetrating, so the inner side won't be affected. Switch back to brush 1 for minor adjustments. Remember to disable backmask. A detail: when editing the left side of the shank, the right side moves along with it. In this case, use the drag brush to reduce impact on other areas. This is the difference between the drag brush and move brush. Next, flatten all branch tips. Switch to brush 7, Polish brush. First hold Shift to smooth the surface. The strength is too high, so reduce it first. Smooth. Then polish. Do the same here. Smooth first, then polish to flatten. Apply the same method to all other branches. Finally, refine the sculpted texture details. Switch to a separate window for better visibility. Now, simply deepen or widen the existing textures. Since the ring is small, the texture relief needs to be strong. Use brush 2 and hold Alt to deepen the recessed areas. Some details are too thin, and overly fine details cannot be properly manufactured. Use the inflate brush to widen them. This area is flat. Manually add relief effects. Continue deepening and widening the textures to enhance their three-dimensionality. This way, the texture will be visible when holding the actual product. Retain some irregular protrusions for a more natural texture. The rest is just to keep refining these texture details. Refine the area connecting to the bezel. Editing from this angle is inconvenient because it's blocked by the other side of the ring shank, so we need to hide the left part of the ring. Click Lasso Hide and lasso the area to hide. This eliminates obstruction. Reference the original texture to enhance its relief details. Now sculpt the other side of the ring shank. Swap hidden. Finally, show all parts. Sharpen some lines using the pinch brush. That's the complete process for making this branch ring. Due to video length constraints, I won't go into further refinement. That's all for this video. Thanks for watching this far. If this video was helpful to you, don't forget to like, share, and subscribe to us. See you next time.